Hello again. In this video we're going to be looking at the numerical model in biomechanics. The numerical model is used to analyse sporting performance and technique using numerical data. This is a form of quantitative analysis and uses kinematics and kinetics to interpret technique and performance. Kinematics is the study of movement, which can be movement of objects or people. Kinetics is the study of forces, which cause this movement, like gravity or friction. These forces can be separated into linear and angular motion. Motion is the changing position of an object from its initial position to its final position. This means that linear motion involves an object moving in a straight line from one point to the other, whereas angular motion is the motion of an object or body about a fixed point or axis. Also, projectile motion is a mixture of both linear and angular motion. For example, if you bring the ball up the court in a basketball game and change direction to get past the defender. Numerical models can be created from a few different things, like literature based from reliable research and journals, elite athletes, or a combination approach by getting an average ideal numerical model from literature and athletes' data. For example, an athlete may have the highest jump using a 120-degree angle, and so people may use this angle, or a biomechanist may say that you will get the most height on your jump when at a 90-degree angle. So you may use this, or use an angle in between, which suits you most. A force is an interaction causing an object to be pushed or pulled in a specific direction, and is a product of the mass and acceleration of an object or person. Also, a force is a vector, meaning the magnitude and direction are both required. A force will change an object's state of inertia, which is an object's tendency to stay unchanged or resist any change in motion. For example, if a golf ball is still on a golf tee, it will stay the same unless there is an unbalanced force acting upon it. Therefore, when the golf club hits the ball, a change in motion is caused as there is an unbalanced force. In order to measure a force, you will need force plates, spring scales, a strain gauge or a Newton meter, and these will measure the force in newtons, which is the measurement for any force. A force has many different effects on an object. These include the creation of motion, change in acceleration or deceleration, change of shape or size, and change in direction. For example, when a tennis ball is hit by a racket, the ball will squash, and therefore the size and shape have been changed. Also, if a football is kicked and is travelling in the air at a constant speed, but there is a sudden gust of wind, the ball may accelerate more or decelerate if the wind is blowing towards the ball due to air resistance. Also, if a rugby ball is on the tee, when the ball is kicked, motion will be created. Finally, when the basketball is hit from a tip, this causes an increase in acceleration and a change in direction. In general, there are three types of motion, consisting of linear motion, curvilinear motion, and angular motion. Linear motion is any motion in a straight line. Curvilinear motion is a motion in curve, and angular motion is motion around a fixed axis. Projectile motion is also a type of motion, which is a mix of linear and angular motion. Newton created three laws to motion, beginning with his first law of inertia, stating that every body or object at rest, or moving with constant velocity in a straight line, will continue in that state unless acted upon by an external unbalanced force. This means that an object is very reluctant to change, and only will if an unbalanced force is exerted. This law describes what will happen to an object if the forces are balanced. Balanced forces are equal in opposite directions, which means that there is no acceleration or change in motion, and the net force is zero. Therefore, the force must be unbalanced in order to change an object's state of inertia. For example, a hockey puck would travel along the floor in a straight line at constant speed if friction wasn't acted upon it. Newton's second law of motion looks at the behaviour of these objects when the forces are unbalanced. The law states that an object's acceleration is dependent on two variables. These are the mass of the object and the net force acting upon it. The acceleration is inversely dependent on the mass and directly dependent on the force. Therefore, as the mass increases, acceleration decreases, but as the force increases, acceleration increases. Furthermore, if two sprinters have the same net force, but one is 70 kilograms and one is 60 kilograms, the lighter 60 kilogram sprinter will accelerate faster. Newton's third law of motion shows that for every action there is an equal and opposite reaction. For example, when you bounce a basketball on the ground, the basketball produces a force against the ground, and the ground has an equal and opposite reaction force, pushing the basketball up and allowing it to bounce. A direct force occurs when the line of the force is through the centre of mass, resulting in linear motion. On the other hand, when the line of force is outside the centre of mass, the motion is angular and an eccentric force is produced. When talking about force, impulse is often mentioned, which is the measurement of force applied for a specific time. This means that an increased impulse will result in an increased velocity. Therefore, to increase this, you must increase the size of the force produced, or the time that the force is applied. By changing either of these, the system's momentum will change also. Momentum is the product of mass and velocity, and so it shows the amount of motion there is in a moving body. Therefore, if an object is heavier but is able to produce the same velocity, then its momentum will be higher. For example, in shot put, athletes will spin for a period of time in order to increase velocity, so they have a higher momentum. Stability looks at how difficult it is to change the body from a balanced to an unbalanced position. Stability looks at the centre of mass, line of gravity, and the base of support to decide how stable an object is. A person's centre of mass shows the point where the body is balanced in every direction and is the average position of all parts of the body. Therefore, for a simple object like a football, the centre of mass would be in the centre of the ball. The centre of mass in humans is usually just above the hip bone when standing in a balanced position, but every time we move our bodies, the centre of mass will usually change, and sometimes we use certain positions to change centre of mass to increase or decrease stability. For example, when defending in basketball, you stay low and bend your knees to lower the centre of mass and increase stability. The base of support is the area of the surface beneath that the person or object makes contact with. This can be a part of the object itself, like a person's feet, or something that is helping to keep the object stable, like crutches or a walking stick. The line of gravity shows the direction gravity is acting upon a person or object from the centre of gravity. If the line of gravity falls outside of the object's base of support, the object will become unbalanced and fall. In order to increase stability, the base of support can be widened, as this will help the line of gravity stay within the base of support. Also, you can lower your centre of mass by lowering your overall position, which also increases stability. However, sometimes people need to decrease their stability. For example, a rugby player will lean forward when making their tackle, moving the centre of mass outside of the base of support so they can take a player onto the floor. Before participating, I must create a par cue for the participant to sign. Once this is done, they will do a warm-up and I will explain the protocols to them whilst they are warming up to save time for them to do at least 3 attempts at the vertical jump. However, before they do the test, many things have to be set up and put in the best position for it. One factor that needs to be chosen is whether to use 2D or 3D imaging in order to assess this. 2D is good because it can be very cheap, but 2D cameras can still be very expensive if you want a very high quality camera. Also, it's very easy to record and very reliable. However, 2D can only show you one angle of what they are doing, so you must make sure you select a good camera angle, or angles, otherwise it can be a waste of time. On the other hand, 3D imaging is very expensive and takes a long time to set up. Also, if you've not been taught or have a trained person, you may not know how to use this equipment, and so won't be able to use it. However, the imaging allows you to see where the joints are and shows you the whole picture of what the participant is doing, which means you do not have to waste time choosing angles or taking multiple shots of the athlete. Therefore, this is usually used for athletes due to the expenses and knowledge needed. The dimension of the camera is not the only thing that needs to be taken into account. You also need to think about the quality of the camera in terms of the frame rate, shutter speed, focus, and iris. The frame rate is important to see the different angle changes so you can see what is good or bad about their technique and highlight what specific times they used a good or bad technique. Having a good frame rate is important so you can see exactly what happened, and you can also use slow motion if the frame rate is high enough. 1000 frames per second is super slow-mo. Also, shutter speed can affect the picture or video by making it blurry or darker or too light. The average on a camera is 1/60, but a higher shutter speed is usually better. As well as thinking about camera quality, you also need to think about the camera positioning. One factor you have to consider is the plane of motion so that you get the right angle, and you may even have to move the camera. Panning is when you rotate the camera in its horizontal or vertical axes in order to keep a moving person or object in view. Also, you could use tilting, which is effectively moving the camera in a fixed position. Not using the correct camera angle could result in a perspective error, which is the false change in length or angle when camera or eyesight is out of the correct plane. Finally, the force plates need to be calibrated to each specific person's weight, and so if you do not know how to use the software, then you will not be able to use it properly. We also weighed ourselves beforehand for any other calculations necessary. I took data from a weaker player, which is person 1, and a stronger player, which is person 6, in the group, and compared both to the mean. Firstly, the better participant had a higher net force, net impulse, and mean power, which should all result in a higher jump. However, the duration of the phase on the ground for the stronger participant was shorter than both the mean and person 1, which suggests that a shorter time on the ground may result in a higher jump. Furthermore, person 6 had a greater mean velocity, acceleration, and time in air, so they jumped higher by 0.29 meters. This shows that person 6 has a much greater technique, and they can produce a lot more force in order to